Hello everyone. So today we will discuss about the chapter triangles from class 10. So earlier in class 9 we have discussed about the relation between two triangles, which was called congruency. Congruency, if you can remember, was when two triangles had equal angles and equal sides. Corresponding angles and corresponding sides were equal. This year we are going to have similarity of triangles. Similarity of triangles is the condition where angles of the concerned two triangles are going to be equal, but the sides, they can be proportional. Apart from being equal, they can also be proportional. Like, let me take example. Here we have taken two triangles ABC and PQR. Here all the angles are equal, all the sides are equal. So these two triangles, they are congruent. Whereas you can see that in these two triangles, the angles are equal, but the lengths are different. Length of each side is different, but the lengths are such that the sides are in such a manner that their ratios are equal, they are proportional, and the angles are equal. So such a case is called similarity, and the triangles are called similar. We should note one thing, that congruent figures are always similar, but we cannot say that all similar figures are congruent. That we have to always remember. Now if we talk about the exercise, the first exercise, it has some objective type questions. So all circles are what? If we talk about circles, all the circles, they are what? Round shape, but they have different radii. That means they are not equal, but they have similar shape, so they are similar. All squares are dash. All squares have right angle. All the vertices, they are right angle. They measure 90 degree each, but the sides can vary. So as the sides are varying, so we can write it as similar and not congruent. All dash triangles are similar, so there are two options. One is equilateral and the other is isosceles. We cannot take isosceles because in isosceles triangle, two sides and corresponding two angles are equal. In one case, the equal angles may be 40 degree each, 40 40 and then 100, and in the other case it may be 50 50 and 80. So the angles are not equal. We cannot include isosceles triangles to be similar. So the only option we are left with is equilateral triangle, as in all the cases equilateral triangle have all angles equal to 60 degrees. So it should be equilateral. Now another question is that the polygons of same number, two polygons of same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. We always have to remember that if two objects are similar, then their sides must be proportional and their angles must be equal. Next, we were asked to draw two sets of similar and non-similar figures. So I have taken two squares. Two squares are similar and two circles, they are also similar. Talking about non-similar figures, I have taken two triangles where one of them, if you can see the corresponding angle, one of them is acute and the other corresponding angle is right angle. So clearly it's visible that they are not having same angle, so they are not similar. Here if you can see these two figures, these sides are equal, all the angles are 90 degree. Basically this is a square, all sides equal, all angles 90 degree. Here in this quadrilateral, all the sides are equal, but the angles are not equal. The angles are not 90 degree each. That means they are dissimilar figure. Now let us talk about the first theorem of this chapter, basic proportionality theorem, or it is also known as Thales theorem. So what does this theorem say? If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, the other two sides are divided in the same ratio. Like suppose we have this triangle ABC where DE is a line that is parallel to BC, then according to this theorem, AD by BD equals to AE by EC, AE by EC. So these sides are divided proportionally. So how to prove it? We construct two perpendiculars, one from D on AE and one from E on AD, and we join these 2 points. We join BE and CD. Now what happens in this triangle ADE? We have two perpendiculars, so we can find out the area of the triangle in two ways. We have area of triangle equal to half into base into height. If we take DM to be the height, then AE is going to be my base. If we take EN to be the height, then AD is going to be my base. So we are going to write it in two different ways. One taking EN as the perpendicular, while the other is taking DM as the perpendicular. Now talking about DBE, this is obviously an obtuse angle, so its perpendicular is out of the figure. En is the extended height of the triangle, so its its area will be half into BD into En. Similarly, talking about DEC triangle, this is also obtuse, so its height is DM outside the figure, so DEC's area is half into C into DM. Now let us divide one more thing, as we have learned earlier from areas of parallelogram chapter in class 9, that whenever we have two triangles standing on the same base and between the same parallels, then their areas are equal. Similarly, what happened? These two triangles DBE and DEC, they are on the side DE and between the same parallel BC, so the areas are equal. Now let us divide triangle ADE by triangle DEB, both the areas. So ADE I am keeping it the same, but DEB I can write it as DEC from this. Now I will place their values. I am taking one set of value of AD here and the other set there. Upon writing the values, I see that many of them just cancelled out, leaving behind AD by BD and AE by CE. This is ultimately the proof that we need, that AD by BD equal to AE by CE. AD by BD equal to AE by CE. One more thing we should know, that in certain cases we can also write AD by AB equal to AE by AC. If you are taking the upper part and the whole part, then you should also take the upper part and the whole part of the other side. If you want to take the lower side, okay, that is also okay. You can write BD by AB equal to CE by AC. That is also feasible. Now there is a converse of this theorem, converse of BPT. According to BPT, if this internal line is parallel, then the sides are proportional. And according to the converse of BPT, if a line divides the two sides of a triangle in a proportion, if the ratios are equal, then that particular line will be parallel to the third side. In BPT, if the lines are parallel, then the other two sides are in proportion. And according to the converse of BPT, if a line divides any two sides in proportion, then the third side must be parallel to this line. Now let us come to the second exercise. Here the first question asks that if DE is parallel to BC in triangle ABC, then out of the four segments, three of them are given. We have to find out the fourth one. So simple, it's very simple. DE is parallel to BC, so we will apply BPT. AD by BD equals to AE by CE. In that way, AD is 1.5, BD is 3, AE is 1, and we have to find EC. That way EC comes out to be 2 centimeter. In the second case, the values of these three are given. We have to find AD. In a similar manner, we will just apply this BPT, AD by BD equal to A by AC, and find it out to be 2.4 centimeter. The second question, question number 2, what it says is that PQR is a triangle. E and F are points on PQ and PR. The values of PE, EQ, PF, FR, these are given. We have to compare their values, their ratios, and find out whether EF is parallel to QR or not. So what we will do is that we will find out the ratio of PE by EQ and PF by FR separately. PE by EQ, which is simplified to be 13 by 10, and PF by FR, which is simplified to be 3 by 2. Since these two values are not equal, so I cannot say that EF is parallel to QR. Let us take the second case. So here PE and QE are given. So PE by QE is simplified to be 8 by 9. On the other hand, PF by FR is simplified to be also 8 by 9. So in this case, both the ratios are equal. So by converse of BPT, I can say that EF and QR are parallel. I repeat, since these ratios are equal, they are proportional. So by converse of BPT, I can say that these two lines are parallel. So now the third one is a bit tricky. You are given PQ, the entire side, the whole side. Also you are given PR, this whole side. Then PE, the upper portion, PF, that other upper portion. So what we will do is we will find the ratio of PE by PQ and PF by PR. PE by PQ, PF by PR. On simplifying them, both of them reduce to be 9 by 64. That means they are equal. The sides are proportional. So by converse of BPT, I can say that EF and QR are parallel. Now moving on to the third question, they have given a figure like this where they have mentioned that LM and BC are parallel. On the other hand, NL and DC are parallel. So what we have to prove is that AM by AB equals to AN by AD. If we talk about this triangle ABC, AM by AB, the smaller part by the whole part, and that should be equal to AN by AD, the smaller part by the whole part of the other triangle. So we will take these two triangles separately, ABC, ADC, these two triangles separately, and apply BPT on both of them. First of all, starting with ABC, LM parallel BC. So I can say AM by AB. I could have written AM by AMB, but since I need AM by AB, so I will be writing AM by AB. So that will be equal to AL by AC. In the second case, here if we apply BPT, then AN by AD, what I need actually, AN by AD, this will be equal to AL by AC. AL by AC. Now from these two equations, I see that both these values are AL by AC. That means they are also equal to each other. So I have deduced my proposed relation between the sides. Coming to the fourth question, which is also a similar type of questions, where here the two triangles were adjacent to each other. Now this question is sort of, they have just folded the two triangles together. This was like two adjacent triangles attached to each other, and this question is like they have folded one triangle into the other. So what do they want is that, what they want is BF by FE equal to BE by EC. Now we are given with the conditions that DE is parallel to AC. So I guess ABC will be one of my triangle because DE is parallel to AC. So I have separated that. Other condition is DF parallel AE, DF parallel AB. So that will also be a separate triangle. I have separated them, and like the previous sum, We are also going to apply BPT in both the cases, different cases. In triangle ABC, DE parallel AC, so I can write BE by EC equal to BD by AD here, and in the second case I can write BF by FE equal to BD by AD. So both of them turn out to be BD by AD, so I can compare them to be equal. So BF by FE equal to BD by AD. Now the fifth question, this is the diagram they have given. In this figure they have informed us that DE is parallel to OQ and DF is parallel to OR. We have to prove that EF is parallel to QR. So what we will do is that DE and OQ are in this triangle POQ. We will separate it out, and DF and OR in this triangle POR. So we have also separated that out, and we will apply BPT individually to both the triangles. Then we have PE by EQ equals to PD by DO. Here we have PF by FR equal to PD by DO. Now why am I finding out the relation between these two? See, we have to show that EF is parallel to QR. So the only way that we know right now is that if I can prove that PE by EQ equal to PF by FR, then by converse of BPT I can say that these two lines are parallel. So we have taken these two triangles separately to somehow show that PE by EQ equal to PF by FR, which we need for this. So we have separately applied BPT to both of them, POQ triangle and POR triangle, and found out that both PE by EQ and PF by FR are equal to PD by DO. So that means they are individually equal to each other. Now if I take this condition and apply it here in this triangle PQR, then by converse of BPT I can say that EF parallel QR. Next, question number 6. Similar sum, just a bit different in the drawing, in the construction of the diagram. Here what happened is that they have taken the same situation, renamed them as ABC and PQR, and the lines are just jumbled upon. So what we will do is that here we are said that AC is parallel to PR, here AB parallel PQ. We need to show that BC is parallel to QR. This side parallel, that side parallel. We have to show that this BC and this QR are parallel. So what we will do, we will segregate these two triangles out and then apply BPT individually to both of them. Then what will happen is that in this triangle POQ we will have OA by AP equals to OB by BQ. OA by AP equals to OB by BQ. And in this triangle POR we have OA by AP equal to OC by CR. So what we find out that both of them are OA by AP, that means these two are also equal. OB by BQ equal to OC by CR. If we take this condition and apply it to this lower triangle QOR, OB by BQ equals to OC by CR, then by converse of BPT we can write BC parallel QR. So by now I think you have understood that almost all the sums are same, just the diagrams are different. The very structure of the sum is the same. We take out two triangles, we just compare them, we take out any two triangles from the diagram, whichever is feasible for us, we apply BPT into that, and then either we prove them to be equal or we use that equality on the other triangle to show that one side is parallel to the other using converse of BPT. Coming to question number 7 and 8, these two questions are similar in one way and opposite on the other sense. Talking about question number 7, here they have said that if we are considering it to be a triangle ABC, the question says that if you take the midpoint of any side of a triangle and draw a line which is parallel to any other side, then the point where this line meets the third side will be the midpoint of the third side. Simply speaking, if P is midpoint of AB and PQ is parallel to BC, then we have to prove that Q is the midpoint of AC. How are we going to do that? Is that simply we will take ABC triangle, PQ is parallel to BC, so we will apply BPT. On applying BPT, we can write AP by BP equal to AQ by QC. Now AP and BP are equal because P is the midpoint. AP and BP are equal. So AP by BP is what? 1. So AQ by QC is 1. That means AQ and QC are equal. If AQ and QC are equal, that means Q is the midpoint of AC. Very simple. In this case, question number 8, they have said that both P and Q are the midpoints. We have to show that PQ parallel BC. Earlier we were supplied with the information that PQ was parallel to BC, P is midpoint, you prove that Q is the midpoint. Now they have informed us that P and Q are the midpoints and we have to prove that PQ parallel BC. So PQ parallel BC, that is our target. Now P is the midpoint of AB, that means AP equals to BP. Q is the midpoint of AC, that means AQ equal to QC. So I can write AP by BP equals to 1. Same, AQ equal to CQ, so I can write AQ by CQ equals to 1. Since both of them are 1, so these fractions, these ratios are also equal to each other. But think about this condition in this triangle, AP by BP equal to AQ by CQ. That means what? The sides are divided in the same ratio. Let me apply converse of BPT. That means PQ parallel BC. Coming to the 9th question, it's a bit different. According to the question, ABCD is a trapezium where AB is parallel to CD. Now we have to show that their diagonals who meet at O, we have to show that AO by BO equal to CO by DO. What we do is that we construct a line EO which is parallel to AB. Now if EO is parallel to AB and AB is parallel to CD, then we can say that EO is also parallel to CD. So let us take two different triangles where, see, our target is AO, BO, CO, DO. So we will take such triangles where we will get all these 4 line segments. So we have taken ADC triangle, ADC, and we have taken ABD triangle. Here we can get AO, CO, BO, DO. So first we will apply our BPT in ABD. Here ABD, what happens is that we can write that DE by AE equals to DO by BO. Again we apply the BPT theorem here. So we can write DE by AE equal to CO by AO. CO by AO. Now since both of them are DE by AE, so I can write them to be equal individually. DO by BO equal to DE by AE. CO by AO equal to DE by AE. Since both of them are DE by AE, so I can write that these two are equal. These two are equal on rearranging. On rearranging, I will take AO there and DO here. It's called alternando. So I have finally found out AO by BO equal to CO by DO. Now the last question of this exercise is just the converse of the previous sum. Earlier in in question number 9, it was given that ABCD was a trapezium. We had to prove AO by BO equal to CO by DO. In this sum, we are given this condition that AO by BO equal to CO by DO, and we have to prove that ABCD is a trapezium. If we want to prove ABCD is a trapezium, then we have to prove AB parallel CD. We have to prove that one pair of sides are parallel. So let us start by drawing a extension, one construction, we will have to draw EO parallel AB. Now we are given that AO by BO equal to CO by DO. Let us rearrange. See, AO is not connected to BO in a straight way, it is connected to CO. AO by CO in a straight line and BO DO in a straight line. So let us rearrange and bring CO here and BO there, alternando. So we have AO by CO equal to BO by DO. Now let us apply BPT on our triangle ABD because we have taken EO parallel AB. EO parallel AB. So simply we can write that AE by ED equals to BO by DO. Now BO by DO is AO by CO. BO by DO is AO by CO. We have kept that side same. If we take this condition and apply it here in this triangle ADC, AE by ED equal to AO by CO, AO by CO, AE by ED, AO by CO. We find that these two sides are in the same ratio as these two sides. So by applying converse of BPT, we can write that EO is parallel to CD. I am repeating again, AE by ED and AO by OC was found to be same. So by converse of BPT, I can say that EO and CD are parallel. Now, according to our assumption, EO was parallel to AB. Now we have found out that EO is parallel to CD. EO parallel AB and now EO parallel CD. So that means AB is also parallel to CD. If both of them are parallel, so what happens is that ABCD turns out to be a trapezium.